friends. In the series of learning computer organization and design, today the topic of discussion is basic computer organization. So, this particular chapter is very important in order to build the foundation of understanding what is the internal computer organization within the digital machine. Okay, so here is the overview of what we are going to discuss in this entire chapter of basic computer organization. So today we will focus on just setting up the background of understanding what is the basic computer organization. So that's why we will today understand about what are the instruction codes and what are the various types of computer registers which are existing within the basic computer. So let's start understanding with the understanding of the background information of basic computer organization. So here is the point. Whenever we talk about the processors which are existing within our digital machines, right? So the processor, depending upon the kind of manufacturer, each and every processor is having its own design, or you could say its own architecture. Why this is so? Because every processor has its own configuration. Means every processor is using a unique set of registers, a unique set of buses, micro operations, as well as a unique set of machine instructions, depending upon the specification that that processor is having. But if we talk about the modern machine processing devices, right? So these devices are very complex. The reason being, these are consisting of so many number of registers. This is the very first reason. Second thing is that depending upon the capability of my digital machine, the modern digital machine, I would say, I am able to perform both integer as well as the floating point calculations. Okay, so based upon these things, I am having within my machines existing multiple arithmetic units. So that is the second point. There are so many different kinds of arithmetic units or hardware equipments which are present within the processor. Then third is nowadays the processors, because we are saying that the processors are becoming powerful nowadays. So when I say my processor is powerful, it simply means that the execution time of my processor is very less. Means it executes just within a quick instant of time, you could say that. So how my system is able to execute the instructions, a number of instructions, I would say, in lesser amount of time, just because modern machines are equipped with the facility of pipelining. Pipelining we will discuss in the later part of the sections in more detail. Otherwise, for your understanding, number of processes are capable to work together in order to increase the execution speed of the instructions. So this kind of technology is involved or present in the modern machines, due to which these processors, being them very complex, have the ability to process number of different operations in parallel mode. But as I'm saying, we are talking about the digital computers, right? So from the day one of understanding the computer organization and design, we are only focusing on the digital computers. So reason being, sorry, the modern machines that we are using are basically consisting of these digital gadgets only. So that's why. But in order to understand a complex system, today in this particular chapter, we will focus on how the processors work within a digital machine by considering a very simple specification, right? Now, when I'm talking about the specification, what I mean is exactly. I mean is like if I talk about the modern machine, then I could say, okay, what is the configuration of your machine? You could say, my system is 64 bits, right? And it is having the availability, like you could say that it is having 4 or 8 GBs of RAM available, memory, I would say. And then if I talk about the hard disk, you could say, okay, 1 TB of the hard disk is also present within my machine. So basically, all this kind of configuration is actually leading me to a very powerful processor or powerful machine, which is have the ability to work on the complex problems within a quick instant of time. But we will not focus on understanding this complex machine first. We will have a simple approach in there. We call this approach as a basic computer organization. We will take a one simple configuration, like if I say 14096 into 16. This is the kind of configuration I am going to take. The idea is that here the basic computer is actually of 16 bits, right? And the size of the memory or the RAM is nothing but the 4096 words. That's it. So if the configuration will be simple, right, I would be able to analyze more in more detail about the various things which are associated with the configuration. So let's understand that in more detail. So here is the basic computer which I was describing you a few seconds before. So the basic computer generally has the two components. Okay, one is the processor, another is the memory. So when I'm saying okay, I am using just a basic kind of machine. So normally this is what is essential part required in every digital machine: a processor to process, to execute the process, to handle the instruction, to execute the instructions, and the memory to store the data, okay, within your machine. So two important components are present within the basic computer. So let's understand in more detail about these two components. Now, if I talk about the processor, then I will simply say, okay, this is CPU, nothing more than that. When I am talking about memory, I am talking about simply RAM, nothing more than that. In the in context of the basic computer, okay. So, what exactly is the memory? Let's talk about this RAM first. This particular thing. So memory, we are saying that we are having a memory in the basic computer which is 4096. What does this 4096 means? It means that the memory has the capability to accommodate 4096 data, this time of data in its place. Okay, so 4096 simply means this much of data can be present. The space, you could say that the space for having this much of data, 4096 data or the words, is available within the memory, or you could say directly it is the size. Okay, so let's understand that in more detail. So if I say the memory has this much of capability, if the addresses are starting from 0, then I could say that 4096 are the total number of words that my memory can actually accommodate within the basic computer. This is important to understand. Why? Because it's the memory is not only consisting of the data will be present here. I'm simply talking about the size right now. Okay. So when I say within the memory, I need to refer any particular data. Let's suppose this data is present. Now, how to refer that? We always refer that data with the use of addresses, the address of the memory. Okay, so definitely this 100 data will be present at specific address. Now, how many bits are required in order that the space of my memory is 4096? So it simply means that 4096 is directly equals to 2 raised to power 12, means 12 bit combination, 000, so on up to 12 bits. This much size is required in order to store the 4095 results. This is again 12 times. Okay, so this much of space is available within the memory. Now when I will say some data 100 is present in the memory and I want to read that data, then definitely I need to provide the address. So address will be coming like this, in this way. So in order to understand it in more detail, before that let me make you analyze about this point also. Now this data is actually 100 present here. If I say what is the size of this data, now this data cannot be more than 16 bits. See, because I have mentioned that the size of each word should be 16 bits long. It's also been referred here. So if I am saying it is 100, so I need to represent 16 bits in order to represent this 100 in the binary. That's it. This is what the point is. So every memory is having the data stored in it, and in order to refer the data, what we are having is addresses. So how to determine the address? Just determine what is the size required accordingly. So 4096 is directly equals to 2 raised to power 12. It means 12 bits are required to store the data in this particular memory space. So if I am looking for any specific data, I need to refer to its address first. So this concept is actually as equals to, or you could say that, let me make you understand it with a very small configuration. Let's suppose I am having 8 houses available within a colony. There are 8 houses available. Okay. Now, in order to go to any specific house, I must have the address of these houses. So let's make a thing. So 8 houses are there. 8 means this is a colony. 1, 2, 3, 4, 5, 6, 7, 8. Right. So there are total 8 houses been there, and each house, in these 8 houses, each house is have the capability to store the 4 members. Instead of bits, let me write the members. In each house, 4 members are living. This is the, you could say that the instruction. Okay, so this size is of 4 bits. So in order to determine that in which particular house I need to go, I must have that address. So in order to represent the 8 houses in the binary, I can represent it like this. So it means I need 3 bits to understand, or to understand that which address we need to refer to any specific data, which is of 4 bits, right? So how we will determine that? 000, 001, 010, 011, 0 sorry, 100, 101, 110, and 111, right? So these all are the addresses. Once I have a specific address available, then I can go to that particular 4-bit address very easily. So let's suppose this is how we do. Same is the case with the RAM also. If the size of the RAM is 4096, so we will start from 0 till the 7 or till the 4095, and this 16 is the just the size of the each word or the data. Like here in this house, the size of each house is that it can consist of maximum of 4 members. That's it. So once you have analyzed this particular situation, then it would become very easy to you to understand the whole chapter. So let's proceed ahead. So when we talk about the basic computer, we have learned the specification of the basic computer. Now the next point is instruction. So this instruction can be determined like, if I say a user is entering any particular program, a user is demanding from the machine any outcome, then what will happen? This user will simply write it in the form of a program. So programs are nothing but a sequence of machine instructions. So what user is looking from the machine, the user has the ability to write it in the form of the programs. So what are the instructions actually? So instructions are a group of bits. So definitely when I am saying my machine is of 64 bits, it means that a group of total 64 bits means a group of total 64 binary digits are there that tell the computer to perform a specific operation. Now, these 64 bits group will be there, which will instruct the computer to perform any specific micro operations. Operation here simply means the micro operation, because in the computer we are basically dealing with the resistors, and on the resistor, when we perform any data, then we call that data as a micro operation. So, this is how we will proceed. The next is the instruction of a program along with any needed information are stored in the memory. So definitely, so instructions are always been stored in the memory along with the data, right? Then what will happen? The CPU always reads the next instruction from the memory. So if the CPU is executing like right now, I'm not doing anything. So what the CPU is doing at the back end of my machine, it keeps on working for the other background operations which are already operational. So definitely, whenever the CPU has to refer to the memory, so it always go to the next instructions address. That's it. So all the instructions, like if I am saying my system has the capability, in the case of basic computer, the system has the capability to work with 16 bits of the data. So it means that this 16 bits are actually present in this instruction register, because this 16-bit data is presented in the form of instructions. So whenever the instruction will come, it has to reach the memory with the use of any particular register. So that register is named as the instruction register based upon the kind of functionality it is doing. So once the instruction came to the memory, the required data is fetched. Now the instruction will go to the CPU. Now the control circuitry. Now whenever it reaches the CPU, within the CPU we are having two different components available. One is the control unit, another is the arithmetic logic unit within the CPU. So what will happen? There will be a control circuit being provided here. This control circuit will translate the instruction into the sequence of micro operation which are necessary to be implemented. So the next point is, as we have already started learning about the instructions, now when we talk about the basic computer, then what is the size of instruction and what is the formula, format you could say. Let's understand both the things in context of instruction. So basically, a computer instruction is divided into two parts. A normal computer is basically divided into two parts. One is the op code. That op is nothing but the operational cost. What operation we have to do, we have to perform for that specific instruction. And the second is the address. What is the address? Actually within the memory from where I can get the data. Okay, so in the basic computer, since the memory contains this much of words, we need 12 bits to specify the which address in the instruction will be used. So in the basic computer, the 15-bit instruction specifies the addressing mode. So the idea here is that as we are learning about the instruction format, so if I am strict to this particular configuration, it simply means that there are 4096 words which are equivalent to 2 raised to power 12 words. It means that 12 bits are required to store the address address of the instruction. And what is this 16? 16 is actually the size of instruction, or you could say the length of instruction. So how this instruction of 16 bits can help me in determining the various other components of the instruction. So instruction is formatted like this. There are first 11 bits, means 12 bits, which we will call them as address bits. Then there comes 13, 12, 13 and 14th bit. If these all bits are 0011 or 010, whatsoever, in whichever form it is coming, I will call them as opcode. And there is a third 15th bit, I will call them as mode bit, right? So let's understand in more detail about it. So when I'm saying I have to perform any specific operation, like if the example has been there, let me erase it so that I can provide you a detail of this concept. This concept is very much important from the point of view of understanding or building the layout or foundation of the course, okay, this computer organization and design. So let's understand that. So how this instruction will come, because we have defined the computer in the computer specification that my system has only the capability to store 16 words. So based upon those words, how those words will arise, always it will come like one, let's suppose, and so these will be the 12 bits, like this. So it simply means that this particular is the address line. So it will refer to the memory and will go to this particular address line, which is starting from 111. Now in this particular address, within the memory some data is present, let's suppose 50. Now what you have to do with this data, this data is to AND with I means what? I here means the mode bit. How to fetch the data? If the mode bit is, for example, for the time being I am just taking it 0. If the mode bit is 0, it will be the direct instruction. If mode bit will be 1, it will be indirect. I will explain you this in the later part of the slide. For the time being, here what you need to do is you need to configure this address of the instruction. Just take the data, place it into the data register, and then and do its and with some another operation or some another data which is available in the memory or in any other part of the machine. Just do the and of these two different variables, and then again store the data. So this is how you will process. So let's understand about the mode bit in detail. Like I said here, this particular 15th number bit is nothing but a mode bit. So what is the significance of having a mode bit? Mode bit simply says that either to process the data directly or to process it in an indirect way. Okay. So direct addressing and indirect addressing are the two outcomes of from this particular 15th number of input. So let's understand this input in more detail. So it is this topic is also known as the addressing mode, which falls under the category of instruction format. So the address field of an instruction can represent either two things. One is the direct address, another is the indirect address. Because there is only one bit present here, which is the 15th bit. So either this can be determining that okay, this is a direct addressing mode, or it could be indirect kind of addressing mode. Now what I mean by this term of direct addressing mode and indirect addressing mode, let's understand that. First is the direct addressing, this particular. The address in the memory of data to use. So whatever is the address present in the memory of the data, we need to use that particular address. So let's understand again. So this is nothing but the instruction. Remember, in the memory, we are not only having the data, but also the instructions are stored here. Okay, so this is the instruction which came like 457. This is nothing but the address bit. Now this has been represented here in decimal just for our understanding. Otherwise, these things will always be given in terms of decimals. Sorry, in terms of the binary numbers. Okay, so this is a decimal data. It will all be given to you in the form of binary numbers. So let's understand that. These address bits are there. We will refer to the memory to this particular address in case of direct addressing because it is 0. So directly I need to go to this particular address within the memory. So right now I am here. So this will lead me to the address of this 457. So in this 457 I will get the operand. Operand is also called as the data. So some data is present, let's suppose 50. I will pick this data and take it into the data register. Now what I need to do is I need to add it with some another data. So this data 50 was in the data register. Now it goes to the adder. This 50 come from here, and this is a cumulator. A cumulator is nothing but a general purpose register. Now, what is a general purpose resistor? I am just making you aware of this in the next slide where we will get to know more about the processor resistors. So here is the thing. This accumulator, let's suppose, is having the value 100. This 100 value came here. 100 plus 50 will lead me for 150. So this accumulator is again storing the data of 150. Got it? So this is how the direct addressing will work. Why it performs the add operation? Because this is the opcode bit. Similarly is the concept of the indirect address, but how to fetch the data in case of indirects that may vary. So let's understand it again. So let's suppose this is the instruction 300 add and 1, right? So the 1 here in the mode bit is determining that it is an indirect kind of addressing. 300 is representing the address of the instruction which I need to refer to, and add is the opcode. Okay, so what I need is I need to go to this particular 300 address and then I will get some data. Now this is not my actually data. So this is the another address because its name is indirect, right? So what we need to do, I need to refer to the address of instruction. So I need to go to this particular address again, and here only I will get the data. So this is a step process in address the address in the memory of the address in the memory, right? Of the data to use. So this is what exactly is indirect address. So again, I will figure out the data present here. 50, let's suppose, again it is having 100. So 100 plus 15 adder will become 150. That is it. That is the entire concept of understanding the direct and indirect addressing. Now, there is one important key term that arises now is the effective address. Now, what I will say in case of direct or in case of indirect, which address actually leads me for the data generation. In case of direct, the modification to access an operand for the compute type instruction or as a target address for the branch type instruction. So the idea is that it will help me in understanding how and what is the target for the data within the memory. Like here, if in case of direct address, the instruction or the effective address would be 457. In case of indirect addressing, then the effective address will be address of address of address of memory. So what is the address of memory? Address of memory is 300. So address of 300. 1350. So 1350 is going to be the effective address format. So this is the entire idea behind the addressing modes and the effective address and what is the instruction. So this is the last point of discussion in this session, which is the different kinds of processor registers which are available within the CPU. So the different processor registers are data register, address, accumulator, instruction, program counter, temporary register, input register, and output register. So what does this means? Like, depending upon the basic computer organization's configuration, now their size is actually varying depending upon the kind of functionality they are doing for us. Like if I talk about the data register is nothing but when I will refer to the memory, I will get the data. Now that data I need to place it somewhere. So I always place this data in the data register. So data register is actually of 16 bit. Why? Because here within the memory, the size of memory used is the 16 bits. So holds the memory operand. Next is the address. Now address register is what? Address register will hold the address of the instruction, right? So for the memory. So this is the address register. It is holding the address for memory. Then is the third. Its size is 12 bits. Reason being address, as I said, this is equivalent to 2 raised to power 12. Only 12 bits are required to determine this size of the address. Then is a cumulator. A cumulator we used previously also. It is called as the processor register or general purpose register. So basically, when we talk about a general purpose register, it has the two capabilities to load and to store the data in one go. So remember this last point when I was explaining you the concept of direct and indirect addressing, some data was coming out from the accumulator. And I said if this is, let's suppose, 100 here and this is 50 here, this 100 will go from here 50, it will become 150. Now the again sum will store here. Now this 100 is replaced with 150. So before it was storing the data, now it is been loaded with the new data. So let's proceed ahead now. Processor register. In the case of basic organization, we are having only one processor register. And for your understanding, the modern machines can have n number of processor registers available. Okay. So here in case of basic computer, accumulator is doing so. Next is the instruction register. So size of instruction, as I said, is of 16 bits. So definitely the instruction register will also have the size 16 bits. And what does it do? It holds the instructions of the address. Then is the program counter. Program counter is nothing but this. So if I have to remain this data with me, like you are using it or machine is using it for its reference in order to sequentially executing all the instructions. So here the program counter is always holding the address of the next instruction. So the next is the temporary register, again as similar to the data register. This temporary register will hold the temporary data. Like if I have to execute the data AD plus B multiply by C plus D multiply by E. So I will be processing this first and this first, and then I will be multiplying these two. So this is how the temporary data, the store of the temporary data will be present here in this temporary register. Then the next two are the input and output registers. In case of basic computer, these are only of 8 bits and 8 bits each. So input register is holding the input characters, output is holding the output characters. So as simple as it is. So this is just the brief introduction of these processor registers. I hope that you have understood the idea of the processor registers, adding addressing modes, instruction mode, instruction in itself, as well as the basic computer. So if you have any doubt in any of the point, my dear students, directly you can talk to me or you can ping me. Thank you so much for joining the session.